In our last tips and tricks installment, we looked at how to use RailClone to easily add hundreds of windows to a facade. In this video, we'll extend that idea and add roller blinds to the windows. For ease of use, these blinds will use the same splines as the windows, and they'll have a randomised openness property to add some lifelike variety to your buildings. Using the same slicing approach as seen in the window tutorial, I've provided segments for the top left, the top right, the top, the default, and finally the bottom inputs. So the first thing to do is to add these to a basic array. To do this, create a new RailClone object and open the style editor. Drag an A2S generator from the items list to the construction view. Create a new spline node and wire it to the generator's clipping spline input. And then in the spline node's properties, pick a rectangular spline that we can use just to set this style up. Now select the generator and turn on Extend XY Size to Area. This will automatically set the size of the array to fit inside this spline. Now change the default segment mode from tile to scale so that the segments stretch on the x-axis instead of tiling. Now we can add the segment, so create a new segment and set the alignment Z to pivot. We're going to do this to all the segments to make sure they connect correctly. Once you've done that, pick blind bottom from the scene and wire it to the generator's bottom input. And now we'll quickly add the other segments. So duplicate the segment node and pick blind default from the scene, wiring it to the generator's default input. Duplicate the segment again and pick blind top from the scene and wire it to the generator's top input. Duplicate again, pick blind left from the scene and wire it to the generator's left top corner input. And duplicate the segment for the last time, pick blind right from the scene and wire it to the generator's right top corner input. Now the segments are in place, but if you look at the top of the blind, you'll see it doesn't line up with the brackets on the sides. So to fix this, select the blind top segment and enter a padding top value of 0.007 meters to move the blind down so that it's correctly aligned. Because of the shape of the brackets, it's pushing the top section along too far. This is easy to fix, just select the blind left segment and enter a padding right value of minus 0.036 meters to close up the unwanted gap in the top row. Similarly, on the other side, you'll need to enter a padding left value of minus 0.022 meters for the blind right segment just to compensate for the bracket on the right hand side. If we look at the row below this one, we can see that because of the chain, the default segment has a large gap above it. Also, the default and the bottom segments are not inset on the sides to account for the top corner brackets. So we can fix this by automatically extracting the size of the geometry in the top row and using it to control the fixed size parameters of other segments. For example, to fix the chain issue, you can right click on the blind top segment and click Export Attributes Size Y. This is going to output the height of this segment, and it does take into consideration any padding values you've added. So now let's use this to control the height of the blind left segment. So select it, right click and select Export Parameters Fixed Size Y. And wire these two exported properties together. You'll see that the gap closes up and the default segment moves up into the correct position. So this is working well, but as you can see there's a problem because the chain is now being scaled incorrectly. In fact, it's being scaled to match the height of the segment in the top row. So we want it to use this measurement to control the segments below in the next row, below the top row. But we don't want it to change the actual size of the geometry. So we can fix this by selecting the blind left segment and turning off Scale Segment. And with this setting disabled, the fixed size value is used to calculate the position of adjacent segments, but it doesn't affect the shape of the geometry. So that's that done. Now all we need to do is to inset the sides. To do this, we're going to add two empty segments to the graph, one wide in the left input and one in the right. And then for both of these, export the fixed size X property. Now export the X attribute for the blind left and blind right segments as well. And we'll use these to drive the size of the empty segments. So wire the blind left segment's X size output to the left segment's X size input, and wire the blind right segment's X size output to the right segment's X size input. So now you'll have added all the correct padding and your pieces should fit together correctly. But at the moment the blind fills the entire clipping spline. So in the next few steps we'll randomise the openness of the blind with a minimum and maximum percentage range of the window's height. And to do this you add a randomised padding value to the bottom segment. But you can't use expressions to control a property of a segment directly. Instead you have to wire the segment to a transform operator and then manipulate that instead. So wire a new transform operator between the blind bottom segment and the generator. Right click on the transform operator and export the bottom padding value. And because we want to randomise this padding, we'll wire the exported value to a new random number node. And we want to randomise it using scene units, so select the random node and change the type to scene units. We want every blind to take its own random value, so change generate on to X blind start. This will change the blind's openness for each individual window. Now export the minimum and maximum scene units parameters in the random node. We're going to add an expression to these so that the random numbers are within a range determined by a percentage of the window's height. This will mean that you can use the style on windows of any size without having to enter specific measured values. So to do this, we'll now wire an arithmetic node to the minimum input. Change the operation to expression, open the expression editor, and then enter y spline length. This is going to automatically find out the height of the current array. And then we're going to times that by input 1, which will be a percentage, divided by 100 to give us a decimal. And that will allow us to determine a percentage of the overall height of the window. So now we need to input the percentage so that we can control it from the modify panel. And to do this, wire a new numeric node to the arithmetic operator's input, change the type to percentage, and we'll limit the range between 0 and 100%. Name this numeric node minimum open. Now select the numeric and arithmetic node we just created and copy and paste them to create a duplicate. Wire the duplicate to the random node's maximum input and then rename the second numeric node to maximum open. So now we have a random node which has the minimum value controlled by a percentage of the window's overall height and a maximum value also controlled as a percentage of the window's overall height. And you can control those percentages from the parameters rollout. So let's do that. Let's set the minimum open value to 30% and the maximum open value to 80%. If you change the seed value, you can see the variations you get using these values, and your final graph should look like this. So the beauty of this style is that we can easily apply randomized blinds to an entire facade. So in this case, we just want to make sure we rotate the whole style so that the blind would face inside the windows when it's projected onto the facade, and then change the clipping path to the window spline, and that's it. Instant blinds with randomized open sizes with an easy to adjust minimum and maximum range derived automatically from the window's height. In this tutorial we demoed a simple roller blind style, and similar techniques could be used to add many other blind types. If you do this kind of work regularly, you might find it beneficial to create a library of generic window blinds and curtains that can be easily reused or adapted for projects. And if you're interested in learning how to create custom libraries for RailClone, check out the last chapter of our Next Steps with RailClone guide. Meanwhile, stay tuned for future training, or for more information about many aspects of RailClone's features, please see our reference section or visit the tutorials page for more tips and tricks videos and in-depth tutorials.